Okay. I would like to welcome you all to our first lecture for Informatics 1A. So I'm sure the guys that are joining this class are from BCom, Information and Technology Management. So last week we met and we did analytical techniques, which is working with Mr. Kudasvanda. And then we also met for economics on Monday. And on Saturday, we made for Introduction to Business Management. So we are only left with one course, which is Informatics, right? So Informatics 1A has got a lot to do with programming. So because of its inclination towards programming, I will not be taking you through the course because I'm not a programmer myself. However, I've got a friend of mine who studied business and computing science, who has got some programming knowledge that he has learned through his education and through his work experience. He will be the one who will be taking you through the course. His name is Tino, and he will be assisting you guys. So remember the deal that we made. We are going to do a free class just so that you can familiarize yourself with him. If you're happy with the way he's tutoring, and then you want to continue with the classes in March, then you can pay the fee, which is 800 Rand, which will include exam preparation and also include the 2 assignments that you are supposed to do. In the event that you don't want to join the classes, but you still need assistance with your assignments and assistance with your exams, feel free to text me or WhatsApp me so that we can make a separate deal, which is not on the lessons. But I hope you are going to have a wonderful time with Mr. Tino. And then if there are any issues, please feel free to post them in the group so that you can get assistance on the issues. Then I think myself, I'm going to be attending another class in a few minutes, so I will not be attending this one. But if there are any issues, post them in the group. I'll take care of them after my class. I hope you enjoy your time. Mr. Tino, over to you.
Okay, thank you so much, Mr. James. Welcome everyone to Informatics 1A. I hope I find you well. As Mr. James has introduced, my name is Tino, so I'll be taking you throughout this semester, Informatics 1A. So, what is informatics generally? In this course, we are going to learn more on Java programming language. But before we proceed, we need to know the basics, the foundations of programming. So as when you are going for your second year, you'll be doing deeper programming again. But throughout this module, we'll be doing the basics of programming. So in this unit, our first lesson is Mr. James' stage. We are going to do the introductory. The introductions that we are going to do, I would appreciate if all guys who interact, if you have any questions, just send your messages through. I hope I'm audible to everyone. Just send your message in this group, in the chat. You can simply type your query where you are not understanding so that we move together. Okay. So basically, in this unit, Introduction to Algorithms and Programming. So everyone is expected to understand the concept of programming, features of a good program, and maybe we are going to just do the basic or the surface of system development cycle as we move on to the real programming using the required IGL of Java. So by definition, what is the computer program? The concept of programming. Computer programming is creating a sequence of very precise instructions written in a language the computer understands. So what we are saying here is a computer program, each and every computer program, it does what we feed it to do. So it performs instructions that we provide to it. So to perform a specific task with a computer, we write a code as programmers, as we are going to learn how to do it, maybe in our next lesson. You write a program with specific and precise instructions on what that program is going to perform. So computer programming, often short-coded to programming or coding, is the process of writing, testing, debugging, troubleshooting, and maintaining act of instruction. So when we are writing a computer programming, we follow a certain sequence, what we call an algorithm. We are going to discuss more about algorithm shortly. So some programming, what we have to do is maybe we are going to modify already existing program, maybe debugging it so that it suits or it solves the given problem at hand. So the source program is written in an acceptable programming language. So there are so many programming languages that programmers can use. They can use Python, they can use C++, they can use Java, etc., etc. So a computer programming will use that high-level programming language, which is Python or Java, and it will give us back the output. So the user will enter the input through what? A code, a program, right? So the code may be a modification of an existing source or something completely new. So in this real world, in this era of technology, because of time and etc., people end up to modify programs or to modify code. Why? Because they are reusable. You can use a code, maybe just adjust a few lines or to modify specific lines to come up with a new code. So all this is part of what? Programming. Why do we reuse a program? Maybe it can solve that program given small period of time. That's why we are going to maybe modify existing source or existing program at hand. So problem solving on computer is a task of expressing the solution to the problem in terms of simple concepts, operations, and computer code to obtain the results. To achieve this, you may proceed as follows. So here we are going to discuss the features of a good computer program. A good computer program should be reliable. What do you mean by reliability? Any developed program for a particular application can be dependent upon to do what is supposed to accomplish. For instance, we have a computer program that we all know, the one that we are using here, the Microsoft Word. It does exactly what it was programmed for. So basically, that it is very, very reliable. Right? I hope we are all together here. And I'm also audible to everyone. Then we move on for another feature of a good computer program. A good computer program meeting users' needs. When you are solving a given problem, and a company maybe, for example, it has consulted you as a programmer saying, we need a certain system to do this and this, maybe a prepaid electricity system or a banking system. It has to meet users' needs in a way which is efficient and effective without giving users complications, right? Then another third feature of a good program, development on time within budget. It should meet a specific budget. When a bank, for example, FNB has consulted you as a programmer saying, we need a program, maybe a banking app. So you as a programmer, you present your budget, you do a feasibility study for that program and say, I need this and this and this. So when you have presented your budget to the F&B, maybe another company has consulted you, it needs to meet that budget. Let's say time, cost, say they may say, we need that application in 2 months' time. So as a program, that program should meet that specified budget of time and resources given it to you. That's another feature of a good program. Again, another feature of a good program, it should be error-free set of instructions. For example, the one we are using here, an FNB application. That application should be free from errors. Let's say when you have constructed or make your applications to work even offline without internet, you can request the balance without the need for Wi-Fi. So when you present your application or your program to the bank, they can test it and it should be free from errors, right? It's another feature of Of a good program. Then we go on to error-resistant operation. A good program should be designed in such a way that it can perform validation run on each input data to determine whether or not they meet the criteria set for them. Reasonable check, existence check, dependence check. So basically here we are saying that program should be dependable upon when you present it to FNB bank, right? So another feature for a good program, since we are using FNB application as our program, that program or application should be maintainable code, in the sense that when the bank needs to put in extra feature, or when there's a crash or they want to upgrade that program, they should simply consult you, and you as a programmer, the one who has made that program, it should not take time for you to debug or to put another feature or another lines to maintain it so that it will meet the requirements for the bank. You know, in this technological era, the technology is changing very fast. So they may say, we need to maintain this, we need to improve this on our application that you have made. So as a programmer, you should be in a position that when the bank presented you with that problem, you should not take time to maintain and to improve the feature they are requesting. Another feature of a good program is portability code. What do you mean by portability code? As you all know that we have different operating systems in the world. We have Android, we have Windows, and we have the Apple applications. So when we are designing your program, it should be portable in the sense that even when you try to install it in an Android phone or Android version, it should be compatible. It should not be heavy so that it starts to drag or the performance of that device will drag. So portability of a code, when you install it maybe in a Windows with 64-bit or 32-bit, your code should be compatible. That's another feature of a good program. Readability. It's another feature of what? Of a good program. When you present, have you noticed that when you are trying to install a program from, maybe you are downloading it from the internet, maybe you are downloading Chrome or Mozilla Firefox. That's an example of a program. You see, there is a documentation part whereby you read the instructions, or when you present that program to another person or to another partner, when you have designed that program, you should have a documentation so that it will be readable, or you should present it with comments within that program, so that when you give it to someone, it will be easier for them to read and understand. Or in your absence, you are not feeling well, they can read and debug it without complications. That's another feature of a good program. Let's move on to storage saving. A good program design is not to be verbose. That is, it will not be allowed to be unnecessarily long. This goes back to the issue of compatibility. Your program should be compatible. It should not take big storage. Let's say when you're trying to download maybe a Firefox or Microsoft, you cannot start. It may be 1 gig or megabytes. It should not consume much storage in your device. Maybe it's a laptop or a mobile device. Again, it should be efficient. The running of that, maybe we are using the Microsoft program, it should be very, very, very efficient and should not slow down the performance of the device. It should not consume a lot of memory. That's another feature of a good program. So there are a lot of features that we can all discuss here. Robustness, usability are some of the features of a good program. All right, we can now move on to algorithms. What is an algorithm? As you are writing your program, you have to follow a certain sequence, the flow of your program from this step to another step, from input, processing, and output. So basically here, we need to understand what is an algorithm, features of an algorithm. How do we present an algorithm, right? Those are the four major concepts that you should grasp for you to understand what an algorithm is. Okay. The concept of an algorithm. An algorithm is a set of instructions to obtain the solution for a given problem. So when you are writing a program, you are trying to solve a given problem, right? So for an example of an F&B application, what are we trying to solve there? We are trying to solve the issue of queues at the bank. So there's no need to go to the bank. Maybe the issue we are solving here is we have limited ATMs around a suburb or around country or within the country. So we will approach you as a programmer saying, no, we don't want people to come to the physical bank every day saying, I need to transfer money, I need to do this and this. So that's why they came up with that was the problem for F&B. That's why they reached a certain programmers saying, guys, we need you to solve this problem. We don't want people to queue on our physical premises every day and saying, we want to transfer this, we want to solve this. Let them do or does everything on their mobile phone at the comfort of their homes, right? So when they are designing that program, to solve the application, they have to follow an algorithm, a set of instructions which comes from input, processing, and output. That's whereby we have the what? An F&B application on our mobile devices, whereby we can easily log in, do everything there. We can purchase electricity. It does a lot of things. So that's another feature of a program. A program can do a lot of things, right? So an algorithm here, we have our problem. So we are now constructing what? We are now designing a program. We follow what we call algorithms. So computer needs precise and well-defined instructions for finding solution of problem, right? So if there is any ambiguity, the computer will not yield the right result. So the issue of ambiguity, our algorithm, our program, as we have defined earlier on, a computer only understands or does exactly what we have presented it to do. So it doesn't tolerate ambiguity. So we need to give it precise instruction, right? It is essential that all the stages of solution of a given problem be specified in details, correctly and clearly. Moreover, the steps must be organized rightly so that unique solution is obtained. So algorithm should be an organized way to solve a program step by step. All right. A typical programming task can be divided into two phases. Guys, we need to grasp this concept of algorithm. A problem-solving phase. In this stage, an ordered sequence of steps that describe solutions of problem is produced. The sequence of steps can be called an algorithm. Implementation phase. In this phase, the program is implemented in some programming languages. So an algorithm, we have an algorithm. You can implement it with different programming language, as I have already alluded to. We have so many different programming languages. So given an algorithm, it's now up to you as a programmer saying, no, this I can use Python, I can use C++, I can use Java, right? It's now up to you. You can implement a given algorithm using different programming language. So an algorithm may be set up for any types of problems, mathematically, scientific, or business. Normal algorithms for mathematical and scientific problems involve mathematical formulas. Algorithms for business problems are generally descriptive and have little use of formulas. So algorithms usually are utilized in the mathematical and scientific field. Features of an algorithm. It should be simple and clear. As I have already said earlier on, an algorithm, when someone presented you with an algorithm, you have to read it and understand it clearly so that when you are now designing your program, implementing it now, it should be simple and clear, right? That's the first feature of an algorithm. It should be clear with no ambiguity. This one I've already explained it earlier on. It's straightforward and it should head to unique solution of problem. So every algorithm, it has an input and an output. So as you are inserting your input, it should give you a unique solution, right? Which is very clear to everyone. it should involve finite number of steps to arrive at a solution. So when you are running your program, or it should give you what? The output. That's the same here in algorithm. It should just step from this point, from input to out to processes and to output. It should have a finite number of steps and it should end, right? We go on to number 5. It should have the capability to handle unexpected situations, right? Here, what we are trying to say is your algorithm, in the event that the machine is crashed or there is an unexpected event, your algorithm should give the option saying, should pop an error message saying this is wrong, or what you have input is incorrect, right? It should give you that, it should give the users that opportunity or that room to say this is invalid so that they can try another feature. So it should have the capability to handle unexpected situations. Okay, so those are the features of an algorithm. There is, and as students, I would strongly encourage you to have a strong understanding of what an algorithm is, features of an algorithm, what is the program, and features of a good program. Okay, let's move on to methods of presenting algorithms. So algorithms are statements of steps involved in solving a particular problem, right? The steps to the solution are broken into series of logical steps in English translated form. So programs are written to solve real-life problems. Here we have already given the example of of F&B application, and I have already pointed out what was the problem. And we can have so many problems that have been solved by the program of that application of F&B application. So programs are written to solve real-life problems. So basically, programming is very, very easy. What we are trying to say, what we are trying to solve is everyday life problems. So learning programming, they are expecting you when you go out to the workplace, whether you are working at any organization, we can always implement programming there. We can always come up with an application somewhere, somehow, to solve the real life problems. Okay, so here we are on methods of presenting an algorithm. So following methods could be used to represent an algorithm. So there's method number 1, which is English form. This English form is usually used in the business world where there is no need for formulas. The solving problems is more into descriptive. There's no calculations and so forth. So English form can be used in the in the world of businesses. Secondly, we have flowcharts. So we are going to describe or to dig deeper into each and every one below the lessons. Okay, so we have methods of pseudocode, methods of decision tables, methods of data flow diagrams. So data flow diagrams and flowcharts, they are more or less the same. So it's more like a repetition, although data flow, they are more deeper than the flowcharts. So firstly, we are going to discuss which is pseudocode. What is a pseudocode? A pseudocode is the English-like representation of program logic. it does not make use of standard symbols like flowchart. So this pseudocode is the most easiest way of presenting an algorithm. It is a sequential step-by-step arrangement of instructions to be performed to accomplish a specific or given task problem at hand. It is an informal and artificial language that helps programmers develop algorithms. So here I have an example which says, write an algorithm to determine students' final grade and indicate whether it is passing or failing, right? So the solution is here is, so okay, let us briefly skip this part and discuss all the methods. Then we will come back doing examples, maybe in our next lesson or as we go. All right. We have already discussed about pseudocode as an example of presenting algorithm. Here we have flowchart. What is a flowchart? A flowchart is a representation of algorithm using standard symbols. Each symbol is a new function. Algorithm steps determine which symbol to use to represent it in the flow. Each step is linked to another step by using directional arrows. So these are the features or an example of a what? Of a flowchart, right? So we have a rectangular. So in our next lesson, we are going to dig down or dig deeper much on these charts, how to draw them. Maybe in an exam, they'll say, describe this problem. For example, this problem that I have presented here using a flowchart. A flowchart and a pseudocode, those are the mostly used ones, methods of what? Of presenting algorithm. So we are going to dive deeper on how to draw these ones and solve certain examples or solve real examples whilst trying to write our program. So this is everything about what? About algorithms and programs. So far we have defined and discussed two major things which forms the roots or the foundation of programming. A program, characteristics of a program, what is an algorithm here, the features of an algorithm, methods of presenting an algorithm. So if I may ask someone in the class, do we have any issue so far? Or we can move on to the main or the core element of this module, which is Java programming. So we are going to use what we have learned so far, the program and algorithm, to come up with Java programs and to run Java programs, etc., etc. So far, I want to ask someone: is there any problem that you are facing or that you need clarification on, given the two major concepts that we have discussed, so that we can move on to Java programming? Okay. I take it as an answer on my side that we are all moving together. Okay. So we are going to learn about Java programming. As I already said, we have so many programming languages, but specifically for this lesson, we are going to dwell or to learn much about Java programming. With most programming language, when you write a program and compare it, so Java programming, there are some things, it's a little bit different from other programming language. And it's very, very easy. Anyone can learn Java programming language. But before we continue or move on with Java programming, I would request each and everyone in the class maybe to go and install these things first, so that maybe in our next lesson, we can move together on the same page. But I know some we are going to face some challenges on how to install it, but it's very, very simple. The installation process and everything. So with most programming languages, when you write a code and compare it, the program is translated into machine code. So on this one, I would like us to install the necessary or the prerequisite things that we need to install on our machine. I hope everyone has got a machine which has a good space storage and can accommodate Java applications. So in your study guide on page 15 and page 17, you are going to see these links. I would request each and everyone on our next lesson to install, to download this, to visit this link and install the Java SC development kit 7. So you need to install. It all depends with your specs of your laptop. So you need to install. If your laptop is 64-bit, you need to install the Windows 64-bit. And if it's 32-bit, you need to install 32-bit. So I would request each and everyone to install these important things. The JGasp, you can find it on this link, and they are already there on your on your study guide, the informatics one, study guide, and you can easily access them, so that we move on together on when we are going to create our first program. So we are now going to do the practical one, right? We are going to have an algorithm. Then from that algorithm, we are going to design or write our first Java program. This is going to be our Our unit 2 content. So our unit 2, which is on our next lesson, we are going to create those things. But I would suggest each and everyone, if you are facing problem, you can simply visit YouTube or any internet source whereby you can find how to install these tools, the Java kit and the JGasp application on your laptop. So for today, that was our introductory. So on our next lesson, we are going to do, for those who have just joined us, we were discussing on what is the program and an algorithm, features of any program. And I'm sure we are going to share this recording so that you can have access, each and everyone can have access to it. When we are going to do our next lesson, will be on what? On same page. So for now, I would request each and everyone to go and install these programs on our laptop so that on our next lesson, we will be what? We'll be on the same page. So thank you guys for your time. And this is just for the introduction. We will meet next time when we are going to, next time we are going to do a small recap of what we have done today and starting to what? Develop our first Java program. Thank you guys. Is there anyone with a question or a suggestion on how we can move on with our lessons? Oh, okay. I take silence as everything is good. Thank you guys for your time. Have a wonderful night. Meet you next time. Thank you. Yes, the sessions are being recorded. And Mr. James is going to share to you all what we have done so far. And please, guys, don't forget to download all those things so that we can start our Unit 2 on how to create Java programs. Thank you so much. Yes, we can use different EDL on how we are going to develop, but specifically for Mancosa, they recommend JGrasp. So yes, you can use IntelliJ. There are so many different platforms that we can use. We can access them from the internet. That way, if you go to your study guide, page 17 and page 15, that's where you can go and find the links so that you can download those platforms. Okay, yes, the link is going to be shared. Thank you, Unge. Okay, Mr. James, over to you.
Okay, thank you guys for coming in. I'll send the link to the group and the Word document that was used into the group later tonight, maybe around 10 o'clock. I hope you had a wonderful time. We'll see each other, I think, on Saturday or on Monday, depending on which module you're doing. Thank you. Good night.